What's up, folks? Welcome back to the channel. In this video, I want to build a simple AI assistant for my personal project notes. So essentially, I organize my projects usually in some notes in Obsidian, where I have tasks, notes, etc. And what I want to do is have an AI agent that allows me to query these notes, gather insight, and help me get more productive with how I take notes during a project. All right. So to do that, we're going to use the OpenAI Assistants API. And it's going to be interesting, all right? So the first thing that we're going to do is kind of outline what this project is going to look like. So the first thing is I'm going to open up ScaliDraw here. I'm going to put my notes here, and let's start thinking about what this thing is going to look. So the idea essentially, folks, is going to be this. I have a bunch of notes in some project, right? So let's just these are going to be my notes. And the notes for a project are usually centralized into one note. So they're usually like one big note. So let me just go back and do this. So you have the central note, which is usually the project note. And then this project note is going to contain references to links and URLs, etc. Right? So docs, PDFs, URLs. But this project note is also going to have links to other notes, to other Obsidian notes. Okay. I would like to take this whole thing, this entire thing here, and I want to build an AI agent on top of this that allows me to, AI agent right here, that allows me to ask queries. So this is the goal. The goal is to have an agent on top of these notes that allows me to programmatically and easily evolve a project, but without taking my control over this project. So I don't want something that does it all. And because the fact that I have notes is because I'm thinking about it, and I don't want to replace that with some AI. What I want to replace is just the low level stuff that's annoying sometimes, making some updates or connecting certain things from notes to different places and things like that. So to set this up, we're going to use the OpenAI Assistants API. And essentially, we're going to have a system where we can automatically, programmatically, given some project note that links to all the stuff that's relevant, automate the process of uploading that to a vector store. And yeah, actually, it's a good idea to now take a look at what the AI assistant is going to look like, right? So it's going to be very simple. We're going to have a system here. The code that we're going to write is going to take in all of this information. So let's use that as like a reference. Let's put it like this. So it's going to take in this project note. So all of this data. And the first thing that's going to do from here is it's going to upload all the files, right? And then to a vector store. So it's going to create to a vector store. And if you don't know what a vector store is, folks, very quickly, when you have any system that has a bunch of files, right? Imagine you have here like a bunch of documents, right? So this is a PDF, and then there's like another PDF, etc. So what happens is when you want to send that to a model like ChatGPT, the problem is that the context length of the model might be too small to integrate all these documents. So what do? We break them down into chunks. We break them down into little steps, okay? So we got like chunk 1, chunk 2, chunk X, okay? So we're going to call these chunks of text or chunks of documents, right? Not necessarily text. And what we do with these chunks is we embed each of these, okay? So for each of these, we're going to embed them. And an embedding is just a high-dimensional representation of the text, where the geometry of the space represents the semantics of the text that's inside. Okay, so we're going to have embeddings for each of these. And what's going to happen is, so I'm going to call this one the embedding one, and the other ones you're just going to remember. Okay, so what happens is we take these embeddings and we organize them into a vector store, which is a space that indexes all these embeddings and allows us to retrieve them when we have a query related to the text or documents that are inside. Okay, so we organize all of these into this vector store, all right? And what ends up happening is this is going to be our vector store, right? So we can call this vector store. And then now we can query this. Okay, so essentially we can start here. We have some query from the user, and this allows us to retrieve relevant docs. And then these retrieve relevant documents essentially will be sent to some LLM along with the query from the user. Okay, so the user might have a question about these documents. So the question is going to come in here. It's going to be sent to the LLM along with the relevant documents related to that. So the query is also going to be embedded first, right? Before sending to the LLM, the query is embedded. So it's going to be embedded, and then it's going to be sent to the vector store, and then we can retrieve it. And then when the query goes to the LLM can now answer a question about, now the LLM can answer the user. All right. This is a very bad brag explanation, folks, but just to give some context in case you have no idea what a vector store is. Now, so we upload the files to this vector store, and now we create our agent. We create our AI agent, AI assistant, whatever it is. All right. So we're going to create the assistant, and we upload the files. Obviously, we're going to connect the files that we create in this vector store to this assistant, and we're going to see how to do that. We're going to have to attach tools to this assistant. And now it's important to know which tools should we attach to this assistant, right? And that's an interesting question. So the way that we're going to think about this is the tools are going to be file search, which is essentially the capability of searching over the files that are in the vector store. And then besides file search, I want to give this model probably some GitHub capabilities, because what I want to try to do, folks, is to see if I can have this model actually make changes to my project's notes autonomously, semi-autonomously, given some input that I give to the model, right? So I want to give the assistant the ability to like make some changes and then commit them to a GitHub repo so I can access them from anywhere. And so I can do some version control over these changes in case the changes are something that I don't like, and I can always go back because we're on GitHub, right? So we're going to create this assistant. We're going to attach these capabilities, right? These are going to be the tools that we have. And then we're going to just talk to it and test out the capabilities. So after we've done all of that, we're just going to come over here and we're going to test across some sample nodes. All right. So that's pretty much what we're going to do. All right, folks. So now that we have all of that going on, so let's go to a Jupyter Notebook. And folks, I'm going to be a little bit more pedagogical today, and I'm going to try to walk you through the entire setup so that in case you're a beginner, you see how easy it is to get started with setting up an AI assistant for yourself. The first thing that we have to do when we have a project like this is we're going to set up our environment so we can install packages, etc. I have a simple automation to do that for me. So I run create make file, and you'll see what happens. And I'm going to say that the name of this project is AI notes something, and I'm going to use Python 3.11. Okay. So now what this does is if I go now on the make file that I created here, I have another automation that creates these make files. And what this does is it gives me everything that I'm going to need throughout this project in terms of automations of the setup, dependencies, etc. So it's going to activate my Conda environment. Conda is how we do dependency management in Python. There are many other ways, and I'm going to upgrade this at some point to something called UV. But right now we're still using Conda. And we have commands to do common tasks like creating the Conda environment, setting up the environment with the right tools, etc., like pip and UV, etc., creating a folder for the requirements of this project. They're going to be updated as we work on the project, setting up the notebook, etc. So what's cool about this, folks, is that now that I have this, instead of having to run a bunch of individual commands, I can just say make all right? And what's going to happen is it's going to do all of the stuff that I just described, but automatically. So I don't have to run individual commands on my terminal, which can be quite annoying. So now it's doing all of that. It's installing all the stuff that I use in these projects, etc. Beautiful stuff. And now, folks, if we go over here, we have the requirements folder. It has the requirements.in file that's going to contain all the basic dependencies that I'm going to need. They're going to be very easy to specify. And then when I want to update the dependency and add an extra package, for example, I'm just going to run a command like make env update, and that's going to create this requirements.txt file, which is going to have all the dependencies well organized. Okay, this is the system I use right now, and I'm pretty happy with it for now. So the dependencies we're going to need is OpenAI for the Assistants API. I'm going to probably need for this PyGithub for the GitHub capability stuff. And I think for now, folks, this is all I can think of. So I'm going to come over to the terminal here, and I'm going to say make env update. And notice that I don't even have to activate my environment, because if I go to make already has here somewhere, there you go. When I run env update, let me just show you this, folks. Env update activates the environment for me and then runs these two commands for compiling the requirements of the new environment with the dependencies I added in the requirements.env file and syncing up, installing everything beautifully together. Okay, so now when I come over here and I run this, we just super fast because I'm using UV, which is awesome. And I could be using just this fellow over here for everything, but right now I just use it like this. And now if we come over to requirements.txt file and we look for OpenAI, we can see that the latest package has been installed, which is awesome. Because now I can come over here, I can select the kernel for my Jupyter Notebook, I can refresh it, and I can look AI notes. And as you can see, I have that environment ready to go. Beautiful, amazing, marvelous. All right. So now let's start with the basic stuff, right? Let's remember the stuff that we've talked about recently. So first we need to set up the notes that we're going to use for this project. So what I'm going to do is I'm going to take all the notes from a specific project that I have on Obsidian and move it to a folder here in this folder that I'm working on right now. So we are a little bit more organized. So notes, I'm going to create a folder called note sample. Beautiful. And now for this note sample, I'm going to come over to Obsidian. I have here a project note that I'm going to use as a reference. And I'm going to just copy this one for now. Yeah, I'm going to copy this one, and then I'm going to paste it here. I'm going to save it as a project note inside the note sample, okay? And now for this project note, we have a bunch of stuff. All I care about in this project note is the reference to other notes within Obsidian, because I want to add those as well. So what we can do in Obsidian to get that, we can show the backlinks for those notes, as you can see here on my right. And now what I can do is I can click and see what node that is. So this is an Scali-Draw drawing, so that's not going to be great. So I'm going to go back. And then let's see, notes, that's also not great. Let's see, nope. Let's see here, no, also no. So let's go back one again. And now if I go to explain spaces, all right, this is now annoying me a little bit because most of my notes are here, which is not, Scali-Draw notes are not what I'm looking for right now. So I'm going to have the resources, the links. Maybe I don't have that many linked notes in this project. Yeah, I have mostly just links. So, okay, so this is good enough. I have mostly just links and not actual extra notes. So I'm going to take this one note. I'm going to get all the links that are inside this node, and those are going to be the resources that I'm going to add to my assistant. All right. So now that I have this node here, all I need to do is extract all the links from this node. So I'm going to try to do that with AI, just so that we're a little bit faster. So I'm just going to go over to ChatGPT. And I'm going to say extract all the links from this node. Extract all the links from this node. Your output should be a list of a Python list of URLs containing all the URLs in this node. Okay, beautiful. So now I'm going to send that out. And let's see what we get. Beautiful. We got all the notes, extracted them. I mean, even if this is not all of the links that are inside, it's fine. I just want to have a references so that we can get this project going. All right, beautiful. So I'm going to copy this. I'm going to go over to my notebook. And now this is going to be the first thing that I have. Okay, I have some URLs containing notes from different places, which are mostly like papers, web articles, or videos. And these are going to be my references, the files associated with this node, etc. Okay, so now that we have that, we have a few things that we got to do, right? And I think that the first one is going to be to create the vector store containing the nodes, etc. For that, we're going to have to scrape the data from all of these nodes and organize it somewhere so that we can store it in locally. So what I'm going to do for that is I'm going to loop over the URLs. Okay, so for URL and URLs, and I'm going to scrape using two packages that are super important: the request package and the beautiful soup package. So I'm going to import requests, and I'm going to import beautiful soup. And for that, we're going to have beautiful soup installed. So I'm going to come over here and I'm going to install beautiful soup. Enable cursor tab, beautiful soup. There you go. And now I can go on the terminal and say make env update, just like we did a second ago. Beautiful. We have the environment updated. I can go back to my notes and I can say from BS4, there you go. Now cursor is already helping me out. And now for URL in the URLs, so for each URL in URLs, we're gonna get a response. This will be the basic setup. However, if we have a PDF, this scraping methodology here is not gonna work that well, right? If I'm not mistaken, but we can test that out. I'm not really sure. So I'm gonna have this. Let's see, requests.get URL. What happens when we do that? Let's see, requests.get. Okay, so that worked. And then if we say .text, I think, let's see, I don't think this works that great. Yeah, I think I would prefer something like Wget. Yeah, not loving this, so never mind. I'm going to interrupt this execution. Interrupt cell, so stop cell execution. Stop it. Okay, I'm gonna just restart this notebook. Okay, folks, so sorry about that. We're gonna have to do a little bye-bye cursor. Yeah, just okay, folks, so now we're going to open it up again. Okay, we've opened up cursor, and what we're going to do is for the PDFs, I'm going to download them with Wget, and for the regular web articles, we're going to do something different, all right? So now where are my notes? Where is my Jupyter notebook? Okay, that's annoying. There you go. All right. So when we have a PDF, folks, what we're going to do is we're going to download it using Wget. And when we have a regular web article, we're going to use requests and beautiful soup. And when we have a YouTube video, I guess for YouTube videos, we're going to leave it aside for now. All right. So YouTube videos, we're just going to ignore. Okay. And yeah, exactly. That's what we're going to do. So for PDFs, let's just, for example, for this PDF, what I'm going to be using is a very simple approach of, if I open up an thing here, I can say wget this article, and I can give it a name. So I'm just going to give it like a name like, in this case, is going to be, I don't know, paper1.pdf, something like that. And wget not found, like this. Okay, so we just downloaded our first paper. So that's the approach that we're going to take when we have an archive PDF, and then the rest is going to be with the regular requests. So for now, This loop is just going to be about getting the text. So text is get text, and then we're going to save it with URL split papa.text. And I'm not a big fan, so I'm going to just call it web page, I guess. I'm just going to call it web page. No, web page, and then like for that we're gonna need to get this thing away. Yeah, web page i.txt, let's say markdown, and for this we're gonna have to, for URL and URLs, we're gonna have a counter. So we're gonna say I equal to 0 and I plus equal 1. And if archive in URL, we're just gonna move on. All right, so I'm gonna say something like continue. Yeah, and then if YouTube, like youtube.com, youtube.com in the URL. We're also gonna continue. Else, yeah, we can actually make it easier. We can say if archiving URL or youtube.com URL, we're gonna move on. Else, we're gonna do the request, get the page, etc. And to be even better, we need to set up some headers to avoid issues with scraping a website. The website doesn't like it. So we're going to have to set up the user agent. There you go. And now when we make the request, we're going to set up these headers, and we're going to set up a timeout of 10 seconds, I guess. And I guess 10 seconds kind of maybe 5, 10, whatever. Okay. So now we have that. We can scrape all those websites. We're going to save them as markdown files. And when we save them, we're going to save them inside of the notes sample. So for that, we're going to set up our notes directory. So notes sample there is going to be notes sample. There you go. So now we have this little this variable here where we're going to save it. So when we save it, the web page resource file is going to be this one. Perfect. And now we can do it like this, web resource file. Perfect. Everything is good now. I think we're ready to try this out, folks. So let's try it out. And URL is not defined. That's funny. So let's save the URL. And this was just a simple test that we did a while ago here. This also was just a test. So now we're doing that, folks. And now we can see if it's working or not. So let's take a look. We're gonna wait a second, and there you go. And we have a bunch of web pages here, folks. And I can go to them, and we can see, click here for now redirected. Okay, so it was redirected. Oh, one we were able to, but it's not very high quality. Quote. Okay, so another one was redirected. So I'm having, as always, some issues with there you go. We got one page from one website that we did not have problem scraping, but the rest we did have some sort of issue or did not scrape anything that useful. So I'm going to delete those. Okay. Okay, another one that we were able to scrape. Perfect. Another one that we were. And then this one. There you go, web page. Okay, so I got 3 web pages, folks. I'm not going to address the issues with scraping because that's too specific for the purpose of this project. In this case, I got a few resources. That's fine for now. We could obviously, given the list of links, since it's not a lot of them, we could just go manually there and take the information from there. But we're not going to do that. We did that, and now I'm going to do a little loop over all the archive PDFs and save them in the notes sample folder under paper1.pdf, paper2.pdf, etc. So I'm going to use cursor here to speed up this process. And it's using the requests, which I do not like. I don't want that. I want use wget, like wget minus o paper i.pdf URL, etc. Let's see if now it works. Okay. Wget, yeah, there you go. I'm not sure that this is possible, but let's see. I've never seen a snippet like this. It's kind of funny. So let's see. Oh, it does work. Nice. That's awesome. That's very cool. Okay, beautiful stuff. So all the papers getting downloaded, folks. Oh, beautiful stuff. So we got a bunch of cool papers. Paper 0, paper 1, Illuminate, perfect. Paper 2 seems to be the same as paper 0. Yeah, I probably have repeated papers there. Paper 3 is something called Prompt. Yeah, these are the relevant papers for sure. Okay, beautiful. We have a few papers, folks. So now we have markdown files, we have papers, and we have our central node here. That's perfect. Because now, folks, what we're going to do is, given all of that we have, we're going to now set up our AI agent. And we're going to start by, creating the files. So I'm going to import OpenAI. So I'm going to say import OpenAI. And now I'm going to set up my client. So OpenAI. And here, folks, make sure that you set your OpenAI API key as an environment variable. I already have it in my system. I'm running this locally. So usually you would have a .m file, and then you load from there. Okay, I don't need to do that. So I'm just going to run this. Works perfectly. Beautiful. And now, folks, we're going to load up the files into our vector store for our AI agent to have, AI assistant to have access to. So to do that, pretty simple. What we're going to do is we're going to say files is equal to client.files.create. And now there is a way to do it across multiple files that I've learned recently. And to do that, I got to remember, because now my memory is failing me. So let's do a little magic here, folks, on the terminal. So for that, we're going to do project, learning, OpenAI stuff, assistant. I'm going to open up a cursor there. And now that we're here, let's go Control-Shift-F, multiple files. And there's a wave, Control-Shift-F, files.content, files.lists, .create. Nope. So let's try another place. Second, folks. I'm going to open up cursor here. There you go. This is the one. Yeah, beautiful stuff, folks. I'm going to take a snippet of code that I have here that does that for us. There you go. This is the one. Beautiful stuff. That's the one. Exactly. Beautiful. So now we can get out of here. And now I have the code in my head and in my clipboard. So let's come over here. And why am I on this thing? That's not what I want. So get out of here. There you go, folks. So this is the code that we're going to need. Clipboard, vector store. There you go. Vector store.create. And we're going to say AI notes. This is going to be the name of this model. And then the file path is going to be, we're going to loop over all the files in the note sample, right? And those are the ones that we're going to upload there. So we're going to say, yeah, that's beautiful. Cursor already helping me out. Note sample dir, web page I. That's a bad way to put it. So I'm going to do it a little bit better. I'm going to use glob. So glob requires us to do multiple types of files. So change it to MD or PDF. Let's see if it looks a little bit better. Accept, markdown, PDF. Beautiful stuff. And now let's see if we got the correct file paths first. So for that, we're going to put stuff here temporarily. And then I'm going to take this vector store also temporarily go over there. And now we can print this and see if it worked. Beautiful, folks. It worked. We have all the files here beautifully annotated, beautifully placed. And now we're going to create these file streams, which is apparently the structure they use to upload these to the OpenAI Assistants API. And we're going to upload and pull. Yeah, we're going to create these file streams, and now we're going to create a vector store. Okay, so let me just delete and get this out. So now we are getting all those files, PDFs, markdowns, and we are reading them as in binary. And then we're going to put them in the vector store. And hopefully this is going to work. Okay. And now we're going to create the batch to upload. So we're going to say file batch, upload and pull. So upload and pull is going to create this session for uploading all the files. And then it's going to pull. And from what I understood in documentation, pull means that it's checking the state of this request that you made to upload all these files. And we're going to set the vector store ID to the ID of the vector store we just created, called AI notes, and the file streams, which is the list of binaries that we created out of the markdown and PDFs that we had. Hopefully I can do that with markdown and PDF. Not 100% sure, but we'll find that out. And then I'm going to print here file counts and status, and let's see if it works. So now I'm running that. It's probably gonna take a few seconds because it's like a lot of files. But hopefully if that works, it means that we'll have a set of files there that we can now access. Okay, so we completed, all the files were uploaded. That's awesome, because now we can create an assistant. So now we're gonna say assistant is equal to client.beta.assistants.create. And to create an assistant, we're gonna need 4 parameters. The first one is gonna be the name of the assistant, which is gonna be AI Notes Manager, I guess. And then the description of this assistant, which is going to be, you are an research notes assistant. You answer questions about the notes in a project, as well as make changes. Let me just put a little, there you go. Make changes to the notes and commit them to a GitHub repo, something like that. All right. And then now, folks, the most important parameter that we're going to set is going to be the tools for this assistant. Okay. So the tools for this assistant is going to be a list of all the capabilities that we want to give this assistant. So for now, I'm thinking that because I don't want this video to be like 3 hours long, I'm not going to do the GitHub stuff right now. I think the changes to the notes and commit them to a GitHub repo maybe will be an update that I'll do in a future video. So you answer questions about the notes in a project, and that's it. Okay, just so that we don't take 1,000 years to finish this one. And now for the tools, folks. Tools, usually, we supply schemas to OpenAI describing the tools that we want. However, we already start with some built-in tools that we can access. And one of them is called file search, which gives this model the ability to search over any files that we might want, which is awesome because now here we have it, file search, and that's all we need to write in this tool. And the model is already going to know that this assistant is going to have access to whatever files we give it access to. And we now have to think, how can we give access to the files that we created in the vector store to this particular assistant? And that's going to be done in 1 second. So wait a second. And besides this tool for file search, what we would like to have. For now, we're just going to have file search. Okay, folks? For now, we're just going to do file search. And after name, description, tools, the other super important, probably the most important parameter is the model we're going to use, which is going to be GPT-4o, which is a standard good assistant model. It's, you know, it's fine. Now, if I go here, I have to remember one thing. Okay, 1 second, folks. We're going to have to remember one thing, which is the assistant. File batch, vector store, file that creates. Assistant. Nope. 1 second, folks, because now I need to, my memory is failing me right now. Oh, there you go. Tools, beautiful model. Yeah, we're good to go with this. Okay. We're good to go with this. So now we can create this assistant, all right? And this assistant is gonna have an ID that we're gonna need for doing more fancy, cooler stuff, all right? Okay, beautiful stuff. Now, folks, we have the assistant created, we have the files created, so now we need to put them together. We need to be able to tell the assistant, look, these are the files you have access to, etc., etc., etc. So to do that, if we go over to the OpenAI API, let me just open it up, right? What they say is, okay, so you give the model access to files, and then what you're gonna do is you create the vector store, you create the file paths, the file streams, and then you do all of the stuff we already did. And now we update the assistant. There you go. This is the code that we need. We update the assistant and we say that the tool file search is going to have access to the following vector store ID. And then we give this vector store ID right here. Okay, beautiful stuff. So now we can come back. We can come over here. We can update our assistant. It's going to have now access to the vector store that we created via the ID that we're identifying right here. Okay, which is really cool. Because now we run this and beautiful stuff. Now it has, and to check out whether or not this thing is working, we can do something. We can come over here on the browser, and then I can come over to the platform, the OpenAI platform. Okay, and then I was already there, but okay, there you go. We can go to Playground, and then we can go to Assistants. And then here in the Assistants, I'm already in my AI Notes Manager, as you can see, folks, which is great. Because now what I can do is I can come over here and I can see that the model has some database attached to it, has file search enabled. So I can ask a question about, for example, what is Luminate? Okay, and let's see if this model knows what Luminate is. So now we send the question to the model, it's running, it's doing its thing. And let's take a look, and there you go. It's a system designed to assist in creative process using LLMs. It employs a framework for human AI collaboration that allows you to explore a range of possible blah, blah, blah. And it used, apparently, according to this little resource here at the end, there you go, page one, it used this paper 1.pdf, which is kind of cool because if we go over to our folder here, folks, and we open up paper1.pdf, we can see that paper1.pdf is precisely the paper about Luminate, which is the tool that I was asking the model about. So we're already working, and we already have a model that's working super well. I mean, we're not optimizing for cost and tokens. As you can see, I spent like 18,000 tokens in this request, but this is for later. Now we have an AI node system working. It's great. It would be nice to update the instructions of this this assistant, and this we could have done directly here in the description, in the instructions of the assistant. We could have said something like something blah blah blah, but I think we probably can if I say client.beta.assistants.update. I think I can say assistant.id. And then I can say instructions, and let's say you are a research notes assistant. Yeah, I'm just gonna copy the description because I think I called description when I should have said instructions. So let's see if I update this with the right instruction. Beautiful. So now, folks, let's see if I update this page. We should see something here. Yes. All right. So yeah, it's the instructions parameter that sets the system message for the model. If you don't know what system message is, it's essentially the message that describes the overall behavior of the model. Okay, folks, so now, I mean, we have a working assistant. This is awesome. It can answer questions about the project, etc. So for example, I could ask, what are my tasks? As you can see here, what are the tasks for my current project? Let's say if the model can answer that. So we can say, what are the tasks for my current project? So let's see if only like that the model can answer correctly. Let's take a look. Running retrieval, perfect. So it is trying out the thing. Determining requirements, exploring whether or not you need a tool demonstration. So if I put this to the side, folks, what would be the requirements for latent space and tool demo, decision support system, idea path to AI interface? Yep. So all of these are very correct, and these are the tasks that I had in my note. So this is awesome because now I really can do, pretty much, I can do some fun stuff with this. For example, I can say, can you write a small 2-paragraph summary of my central project note describing the main insights and ideas of the project so far. So let's see. So we know for this response here that the model used, as we can see in the resources, the project note, which is correct because it's the one that contains the answer for the tasks. Let's see if for this question that I asked for writing a little summary of the current state of the project, let's see if we can get a good answer as well. Okay, so we're looking pretty good. Yep, we're looking pretty good, folks. Okay, using multiple sources. Exploring the concept of LM's design space thinking through the system called Illuminate, enhancing creative process. Yeah, it's not a perfect summary, but also my notes are a little bit confusing. One of the insights is shift from traditional paradigms to model that see computer not as tools, but as means to change and expand thought processes. Okay, it's a pretty nice little summary, even though it's not a perfect summary. So it used the project note. Yeah, it used the right note, which is nice. It's not an amazing summary, but also my notes are very scattered. So it's not exactly like the absolute best. But now let's see what kind of insights are there in the papers referenced in this project that relate to its central idea. So let's see if the model can answer that. So we're going to run that. And we're going to see if the model can actually. Okay, beautiful stuff. So the reference papers relate to your project, discuss a bunch of insights. One, emphasize the value of integrating LLMs in enhanced exploration design spaces, facilitating generative model to develop comprehensive. Okay, this is pretty good. So I used paper 1. It's just using paper 1, which I don't love. I would like to see the model be able to use information from all the papers that we have, right? Paper 2, which is about latent space for guns. Paper 3, which is the prompt 8. And then paper 1, and then paper 0 as well. Paper 0 and paper 2, I think, are the same. Yeah, that was a mistake I made. Okay, but it's fine. It's fine. It went in, it got some paper, it got some insights. Another is use of generic to create structured interaction framework in a co-creative process. Okay, that's okay. It's not amazing insight, but I think right now is just more because my input via the notes are not as high level. So what I can do is now, given that I have this ability to use this AI agent to, ask these nodes, etc., is to come over to my notebook here where we have access programmatically to the assistant and think, how can I make this a little bit better? And one of the things I'm thinking that could be interesting would be, for example, would be the ability to ask for more specific information about a specific paper. For example, I want a summary of this paper, which is paper 0 or paper 2, because I put the same paper twice by mistake. So let's ask the model for a summary of the paper about interpreting latent space of guns. Okay? So to that, I would like to have that as a note that is created and that I can download locally to my machine. So to do that, we're going to have to update this assistant and integrate the tool called Code Interpreter, which allows the assistant to run code, and then we can download whatever files are generated when the model runs that code. So for that, we're going to say assistant is equal to client.beta.assistants.update. And now what we're going to say is tools. We have to actually set the assistant ID. And now we're going to say that the tools are code interpreter, okay? And this code interpreter is just for generating files. It's not necessarily for access to the files that we have locally. So it's not going to need the resources of the vector store. We just want, and I want to make sure that when I update with new tools that I'm not actually replacing the previous tools. So I have to check the documentation for that because I don't remember. So let's see if we can have here, I'm going to open up OpenAI Assistant API, but not a quick start. I want the code interpreter. So let's go over there. Oh, nope. But we can go over to assistants and then tools. And then let's see, code interpreter. So we can create instruction models, tools, etc. Type, resources, stuff. I'm going to just do a test instead of like trying to find that information here. So we see the file search is enabled here. We want to be able to enable code interpreter locally, like in the code that we have. So I'm going to come over here and I'm just going to say to code interpreter and let's see if that actually updates. So I'm going to run that. It worked. And now I'm going to reload this page and let's see what happens. And now it disabled the file search. So that means that when I do that update, I need to integrate the previous tool that we already had and the new one. So I'm going to come over here and I'm going to copy this that we had before. And I'm going to come over here now. And then I'm going to add file search here as well. And now when we run this, beautiful stuff. And not only that, we need also tool resources in the in this update. So let me just put that as well in there. So now it should be correct. And now it should be both enabled with access to the right vector store. Beautiful. So as you can see, folks, correctly enabled with access to the vector store. And now we can write files. So we're going to test that capability right now. And to test this capability, we're going to say, create a summary of the paper about latent space exploration of guns and write it to a file named latentspaceguns.md. So let's test this here, and then we can test it via code in the Jupyter Notebook. And this will be the last thing that I would like to see this model be able to do to be satisfied with this demo sample. So let's see, now it's running, creating a summary of the paper, We're gonna have to make sure that it actually gets the right paper and performs the right action to the paper, right? So we can see that it's using the code interpreter, okay. Create a file named latentspaceguns.md, okay. So now it's running, not super fast, but let's see what happens. I'm not sure, I would have liked to see the file search tool be used first. I'm not sure it was, but we'll see. And then the name of the paper, Interpreting the Latent Space of Guns for Semantic Face Editing. And if we check here the paper, yeah, this, at least we know now that the model actually knows about this paper correctly because it referenced the correct title for the paper, and I did not give that title in the question. So we know that the model fetched information from the paper, and now it is writing the summary, so then it can write it to a file using the code interpreter tool, and finally we can download that via a little magic here on the Jupyter Notebook. But then we had a streaming error. Sorry about that. You can retry the request. That's annoying. So now we had an issue with this API call, even though it seemed like it was generating correctly. Yeah, that's annoying. So it had a mistake. So we're going to update this. Instead of doing this request here in the playground, folks, look at that. When I refreshed the browser, now we can download the file. So that's funny. So now we're going to download this file, Latent Space Guns. Okay. We're going to come back and I'm going to come over here. I'm going to open up the terminal and I'm going to move whatever was in the downloads folder. Downloads and Latent Space Guns. There you go. So Latent Space Guns.md. and I'm going to put it in the node sample, nodes sample. Beautiful. And now we can read it. And that's pretty cool, folks. We have the summary generated. Identifying linear subspace within that correspond to specific attributes, enabling disentanglement of complex attributes. Beautiful. That's awesome. Guns are known for their ability. Okay, so this worked really well. So let's test this capability now from here, from the notebook, so that we can see how we could have gotten access to this file once it was generated. So what I could do is, for this, now we're going to have to run we're going to have to actually run the messages that we've been using in the playground here in the Jupyter Notebook. So for that, we're going to first start by creating a run, okay? And so usually when we have this type of task that we need to do, we need three concepts to be able to do this: runs, threads, and messages. So if we take a look at the Quick Start API, we can see that easily. So you see here, the model is creating some math tutor, and then there you go. We're going to create a thread, and then we're going to add a message to that thread, and then we're going to create a run for that thread. And in our case, we're not going to do streaming, so we're going to do just a basic example. Okay, so let's do that. So first thing that we're going to do then is we're going to say thread is client.beta.threads.create. Okay, and now we created a thread. And now let's add a message to the thread. Okay, so the message is usually something that says what the user wants, right? So we're going to say the role, who's talking? The user's talking, all right? And what do we want? We want the following. We want, let's see. Let's ask for something a little bit more complicated. Let's ask for, what are the points of similarity between the paper Luminate and the paper about latent space stuff, okay? What are the points of similarity between the paper about latent space guns and the Luminate paper? And then let's also say, write the output as a set of instructive bullet points and save it to a file called Luminate Latent Guns Comparison. There you go. Beautiful. Markdown. So this is the message we're going to do. All right, folks? And now we can create a run, because the thread is going to be like a little train that contains a bunch of stuff inside that train, right? That's the thread that we created. And now the messages are going to be the things that we put inside our train. And the run is going to be like, let's turn on that train and let's run it from, I don't know, the source destination to the target destination, whatever it is. So we're going to say client. I don't know if that was a great analogy, but let's take a look. Beta.threads.messages. Beta.threads. Now I'm forgetting again, so let's steal it from here. There we go. We created a thread, and now we say message.create the thread, the role, the content. So yeah, that's true. We create now, but if I do it as a dictionary, I don't need to do it as like this, if I'm not mistaken. Can contain both. The contents of the message application created are added as message objects. Messages can contain text and files. There's a limit. And then create a run. But I'm pretty sure I don't have to do it like this. Messages.create. Yeah, I'm pretty sure I could have done messages. There you go. So that's the create. Messages equal. There you go. That's the one that we're going to do. We're going to go messages equal. This way we don't have to do that create the messages separately. So we're just going to say create a beta.threads.create, and then we're going to say messages equal list of messages. So actually messages equal to messages that we just did over there. All right. So that's it. And this has the information that we want, so we can create a thread. The only thing is that we're creating a run, so we need for this run client beta threads.create messages blah blah blah. And now when we go to create the run, let me just steal it from here. Run. run is equal to runs.create, the thread ID, the assistant ID. There you go. That's it. So it's not, we already created the thread before, so we're going to use the thread ID. So that was the thing I was confusing, folks. Sorry about that. So we're going to say now, so we had this message that we wanted to add to the thread. So that means that what we would do is we would update the thread if we wanted to do that, or when we create the thread, we already add the messages, right? Yeah, exactly. So instead of creating an empty thread that like I did here, what I would do is I would come over here and I would say create, and then I would say messages equal to messages. There you go. This is the correct way, because now we can say run equal to client.beta.runs.create, and now we can say thread ID is equal to thread.id, and then assistant ID is equal to assistant.id. Beautiful stuff. And now the only thing missing when we create a run is we want to make sure that that run, when it stops, like when the train arrives to the station, whatever it is, we get a call, we get a notification, we get some information that, okay, now you're good. So for that, we have, there's a little snippet that I'm going to steal, but not from here. I probably have it somewhere, right? That's very reassuring. So I'm going to steal it from my old project. It should be here somewhere. And there you go. This way I don't have to remember all the little things, but it's very simple. So let me just go back there. Here, beautiful. Okay. So what we're doing here is when the status of the run is completed, we're going to list the messages, right, from that thread. So we're identifying with the thread ID. We're going to print them out. Or not, we're going to print the status of the run so that we get an update. How long is it taking to complete, right? And in the end, when we're done, we're going to have under the messages variable, the information that we want, potentially with the information for the file that was generated with Code Interpreter so that we can download it locally. So I'm going to run that, and nope, not at all. Beta has no attribute runs, so that's not good. Client.beta.runs.create. Beta has no attribute runs. So when I ran the example, I probably .beta.threads. Yeah, we create a run inside of a thread. Threads, yeah. Beta.threads.run.create, yeah. Now we can say, yeah, the run is created for a specific train, right, folks? So perfect. Now it was queued, and if it's completed, do this, etc., etc. Okay, and let's see, run.status. Okay. So Bethesda as the list. That's because we went create, not create and pull. That was my mistake. So here, folks, I wanted to get this to work, but for this to work, we can use the create method. We have to create and pull, because then we're going to only finish this execution of this thread when this thing actually finishes running. So let's try that again with the correct method. And now hopefully, yeah, now hopefully it's going to have the correct, we're going to have the correct thing. So the run was queued, beautiful. Beautiful stuff. Now it's going to take a few seconds. I'm probably going to skip this part. Beautiful. And now we have, folks, under the messages parameter, the information for the answer. So here we're going to have, yeah, that's not correct. It's messages.data. And then it's going to be 0, I guess. Yeah, because we did true. And we can see all the stuff that happened in this call. We can see that there was a file citation. Value. Is there anything else would you like to explore? Yeah, that's nice. So file citation, and then we have the second call, second action, and then here we have the comparison has been saved as a markdown file. Beautiful. You can download it with the sandbox. That's very cool. So as you can see, we have the path, the file path under this that has the location for the file. and the model sent us a message saying, do you want anything else, etc. So this is great because now, folks, what we can do is if I go to message.data.0 if I go to the content, so if we go to content, beautiful, and we go to value, it has no attribute value. That's true because we have to say 0.value. Content 0.value. Object has no attribute content. That's not good. Let me see. Content. There you go. And then it's content text.value. Okay, text.value. I always forget that. Yeah, but that's not what we want, right, folks? I mean, it's nice that the assistant is sending a message back, but what we want is actually under the other element, which is right here. So let's take a look at this. Yeah, what we want, folks, is the information for the ID of the file that we would like to download for the file that was generated, right? So what we can do is that's also in the documentation when we go for downloading the file, the outputs of the code interpreter. And I never remember this stuff, which is terrible. So let's just cheat a little bit. So outputs, there you go, the output files. Content can be downloaded by passing the file ID to files API. There we go. So this is the little snippet, folks, for downloading the file. So now it's very simple. What we're going to do is we have the files.content and we got to have the file ID that we can obtain from here, as you can see from attachments. So what we can see is file generated is going to be equal to what? It's going to be equal to messages. Data1 context.tell.value, that's not true. Messages.data.1 dot something. There you go, dot content. And then it's going to be annotations. There you go. It's going to be 0 dot annotations, 0 dot file ID. And nope, because no attribute annotations. So that means text content block. So maybe text dot annotations. Okay. And now under annotations, we're going to go to file path. Yeah. So we're going to go 0 dot file path. And there you go. And now under file path, we can access the file ID. And obviously we would do this in a much more optimized way in the future, but it's nice to know how the API is structured so that when you're building this out backwards, you know where everything is. So now I have the file that was generated, folks, which is great because now I can use that file here, and I'm going to give this a much better name. So file ID output, file output ID. Yeah. And going to do that, and then file output ID. And this is not an image, right? So it's notes sample, luminate latent space, da-da-da-da-da. And we're not going to call this image data. So it's something else. And beautiful. We printed that to our current machine. And now we can come over here, and this is awesome. Now you can see that the file was generated. Let's go to preview markdown so we can see the actual summary. This is great. And now we can see comparison between these two papers. Latent semantic exploration is, I don't know what the hell this is going on. There you go. Comparison between latent space GANs. So both focus on exploring latent space of models. It's about identifying and manipulating attributes. Luminate discusses using AI to explore solution spaces. Semantic manipulation entails modifying semantics like attributes. Luminate discusses generating creative outcomes through AI assistants in design spaces. That's perfect. Disentanglement and independence emphasizes disentangling attributes to enable independent editing. Luminate, it's about highlights cognitive transformation by allowing users to independently explore and harness new ideas within a structured navigational space. AI tools, adjustments. This is a great example of the value of this type of agent, folks, because this is a file that generated can actually be now integrated into my notes as something that has valuable, high quality insight. So this is super cool. And obviously, folks, this is a very sub-optimized approach, but it's nice to be able to do this, right, programmatically and easily, like in a single notebook, because you can use that to organize how this thing is going to work. And then we could build a CLI tool on top of this to evolve it to become something more. So that's probably something I'll do in the future. And thanks for watching. Don't forget to like and subscribe, and see you next time. Cheers.